Hi, thanks for watching the screencast here. This is the screencast that goes with the virtual day number 2 assignment. So you've got a copy of the slides that go with this lesson in front of you. We will replicate a lot of how we deliver content to you in class through this screencast. So you'll see, as you can see on the slides, there will be times when I'm going to ask you to pause and try something on your own. So we'll just kind of carry on as we normally do if we were all in the room together. The objective for the lesson that is making up for the missed day here is that learners will be able to solve polynomial equations by factoring and using the zero product property. This piggybacks nicely off of what we did in class together on Monday, December the 2nd. So really it is one of those things where the sooner you get this down pat, the better off things will be for you as far as finishing up learning target 18. Our goal is to be able to solve some equations by factoring. So what we really want to do is to take expressions that are polynomial expressions that are ones like we factored in class on Monday and solve related equations to them. We factored things that look like the left side of the equation number 1 here in class. What we want to do now is finish up using a property we learned about long ago to solve the equation. So we want to solve the equation x to the 4th minus 19x squared plus 48 equals 0. So in class we factored this. We thought about this looking like that quadratic form. You've seen many times where I've factored using the box, and I will still do that quite a bit here, but this looks to me like I could factor using the box, only my thing isn't going to be x squared, it's going to be x to the 4th, and it's going to be a 48. So actually the things I can multiply to get x to the 4th are x squared and x squared. This is of that quadratic form. I'm looking for two numbers that I can place here and here that multiply out to positive 48 but add up to negative 19. And without listing all of the factor pairs out there, I'll tell you that the one that I see is is negative 3 and negative 16. If I multiply negative 16 by negative 3, I get positive 48. If I add them, I'm going to get negative 19, and that makes our puzzle fit. This would be negative 16x squared. This would be minus 3x squared. That's the factorization that I need. So the left side of this equation looks like x squared minus 3 times x squared minus 16. Now I do want to check and see if any of those factors will factor even any further. And what I do hope you notice is that we have a case here where this factor can be factored even more. This is a difference of 2 squares. So I could factor that specific factor as the form x plus 4 times x minus 4. Now, the same isn't really true for x squared minus 3, so I'm going to prefer to just leave it in that form. And what I believe I've done now is I think I've completely factored the left-hand side of this equation. So what is still true for polynomial equations is the same factor, the same property that was true for solving quadratics. We've got the whole left-hand side of this equation written as a product, and that product equals 0. So the zero product property applies still. So I can take each of these factors and write equations setting them equal to 0. If this factorization, this product of 3 factors equals 0, then either the first factor equals 0, or the second factor equals 0, or the third factor equals 0. And we can solve each of these equations. The two here are simpler. I think this one is x is negative 4. I think this one is x is positive 4. This one requires a little bit more work, but we could rewrite this equation this way. X squared equals 3. If x squared minus 3 equals 0, x squared is 3. So if x squared is 3, then by the square property of equations, then x either equals the square root of 3, which won't simplify, that's just going to be one of our answers, or x equals the opposite of the square root of 3. And there are our 4 unique solutions, which is how many we would expect. If you want to do the thing where you go off and you write a set, that's cool. Not necessarily needed, but not a bad thing to do either. And a reminder that those don't need to be in one specific order. They can just all be in that set. Okay, this is one that I would then ask you to try in class after seeing number 1. I would encourage you to hit pause and try this one. I will remind you that one of the factoring techniques that often is needed is to factor out a greatest common factor, and you will have that in this example. Hit pause, try this one, and if you get stuck or if you get an answer, set of answers you like, hit play and we'll check it out. There is a greatest common factor in number 2 that can be factored out of the left-hand side here. It's x. If I pull out an x, what I'm left with is x to the 4th plus 3x to the 2nd minus 18 equals 0. And this expression here will factor because it is of that quadratic form, one of the crazy factoring examples. What I believe, and I'm not going to draw the box for this one even though you might have, and that's fine. I think I can do this one with making x squareds in my first terms. And let's see, the two numbers I need to add up to 3 and multiply to negative 18 seems like positive 6 and negative 3. Yeah, that'll work. Alright, and that all equals 0. Are either one of those factorable more? Not really. Neither one of these numbers, neither one of them, this one isn't even a difference at all. This is a difference, and this is a square term, but 3 really isn't. So we're kind of just done with the factoring. But what I can do now is I can apply the zero product property. Either this equals 0, which, hey, that's one of my answers, or this equals 0, or this equals 0. So one of my answers is right here. X is 0 solves this, for sure. I could solve this one. This is kind of a weird case. If x squared plus 6 is 0, then that means x squared is negative 6. And I can solve that equation by applying the square root property of equations. Either x is the square root of negative 6. What would the square root of negative 6 be? The only thing that really we could do to simplify square root of negative 6 would be to rewrite square root of negative 6 as square root of negative 1 times square root of 6. Square root of 6 won't simplify, but square root of negative 1 is I. So we're going to have to do something like I times the square root of 6. Or, another option is the opposite of the square root of negative 6. Negative I square root of 6. Now here, if x squared minus 3 equals 0, then x squared equals 3. I think we actually had this in item number 1. And the square root property says that x either equals the square root of 3, or x is the opposite of the square root of 3. So there are 5 solutions that all work. Let's look at 3 together. 3 says solve the equation x cubed minus 64 equals 0. I can see where you might be tempted to solve this thing for x cubed and then take the cubed root. And one of the challenges you got to be real careful with here is that we have a property that works for square roots. X squared equals something. I don't want you to assume that the similar process works for x cubes. There are actually 3 cube roots of every real number, and you don't know how to find them all yet. So let's, instead of trying to solve for x cubed, let's see if we can factor this thing. What I hope you recognize is that this can be factored as a difference of 2 perfect cubes, because there is a number that you can cube to get 64, and that number is 4. This is really just x cubed minus 4 cubed. So the factorization for something cubed minus something cubed is, you remember the soap thing, the cube of soap? I need first thing minus second thing times, I need the first thing squared. Let's see, same, so opposite. The middle term was thing times thing, x times 4, that's 4x. Same, opposite, always positive. The last thing is the second thing squared. So 4 squared, which is 16. Now we could try to factor this further, but I don't think I know of two numbers that would add up to 4 and multiply to 16. So unfortunately, I think what we're going to have to do is use the zero property and say, okay, well, either this is 0 or this is 0. In other words, we can't factor this one anymore, so we need to start finding our solutions. Now, I'd agree that this one is pretty simple. If x minus 4 is 0, that means x is 4. This isn't factor, though. So we need some method of solving this. I'm going to suggest, even though it may not be the method you might choose, I'm going to suggest completing the square. If you would rather use the quadratic formula, you may. But to complete the square here, I hope you'll remember that what I need to do is I need to get the c term, the number term, on the right side. And then I need to think about what number to add in here. I'll make the box to complete the square. So to complete the square, I need x squared, which gives me x and x. I need to split my 4x evenly. So how about 2x and 2x, which makes these plus 2's. Which reminds me that the number that actually completes the square is positive 4. But if I add 4 on this side, well, I better add it here as well. So what I really have is the left side is now x plus 2, the whole quantity squared. And what I have here is negative 12. And what I want to do now is I want to use the square root property of equations to solve this. I take the square root of both sides. Either x plus 2 is the square root of negative 12. What is the square root of negative 12? What's the biggest perfect square that goes evenly into 12? I think it's 4. And since I'd like to get that negative 4 dealt with also, let's make it negative 4. The square root of negative 4 is 2i. Square root of 3 won't simplify. So what I've got is 2i times the square root of 3, which means x is negative 2 plus 2i times the square root of 3. Or the other option is that x plus 2, one option was 2i squared root of 3, the other is negative 2i squared root of 3. And if I solve that one for x, I'm going to get negative 2 minus 2i squared root of 3. And there are my 3 unique solutions. We're going to pick up in video number 2.